look at is the power circuit for a motor load. And we're going to particularly look at a three-phase motor, although we really could shorten this down to a single-phase machine as well if need be. So we're just going to take a look at the image here on the left-hand side, and it's got the line 1, line 2, line 3, and we're just going to totally take a look at just the power. We're not worried about the control yet. That'll be in a different video, a different portion of this lesson. Okay, so here is our power side, and that goes from our line 1, line 2, line 3, the red, black, blue. It's going to include our fuses. It's going to include all of these conductors here that are going all the way through into our motor starter contactor itself. This is where you're going to make that connection to line 1, line 2, line 3. The red, the black, and the blue. That is into the motor starter itself now. And then from this point, we're going to take a look at that now going towards the other stuff is all internally wired. Now we'll go from the T3 all the way into the motor with all of our okay, this is now our power circuit. So essentially all we're doing is we're just powering that motor, and we've got all the switching controlling aspect of it here. We've got the overload or the overcurrent control up here, and we've got our overload control over here. Now we're going to just transition that guy over to our single line diagram over here. This would be what we would call our wiring and our single line diagram, which is much easier for us to be able to see, for being able to do code calculations and whatnot. It doesn't show the actual individual wires, but I think we can understand what's happening here. So we know that we had 3 conductors that were coming in, 3 wire, our red, black, and blue. Over here we would have our 3 wire, indicating we've got 3 hots coming in. So whatever our load that has to go all the way down, if I have to have a neutral in there, then I've got to put in a neutral. It all depends on what your circuit requirement is. That's part of our power circuit. Now this is our disconnect. In the Canadian Electrical Code, your disconnect will be found in the 28600s. That talks about where it needs to be. It's going to talk about the size it's going to need to be. It's going to talk about if it's an air conditioner or something like that. There's a lot of sub rules, so make sure you're looking through all of those, but in the 28600s. Then we take a look at the overcurrents, and that's the 28200s. We'll talk about the overcurrent devices. We'll go through this all again a little bit later. I just wanted to show you where they are in relation to our single line diagram. Now down here, we still have our conductors. We haven't talked about the AUG size of them yet, but we will in a moment. We still have those 3 same conductors that are running all the way that we brought in from our main distribution into our overcurrent devices here. And then that's this portion right there for the wiring, all the way transition over to here. Then we have our contactor itself. The contactor rating is a pretty simple one. It just really talks about the horsepower rating it needs to be, but we can find that information in 28500. And then our overloads, for the sizing the overloads. Overloads in general are going to be found in the 28300. So all things related to overload and overheating protection will be found there. And then specifically for the sizing of those, we'll find those in 28305. Okay, so in every section of this wiring all the way down so far, we're seeing that we still have 3 conductors. Okay, that chunk right here and the chunk over here, 3 conductors. Now over here, we have to watch out for the temperature rating of those conductors. And that is the only time that we need to worry about the insulation conductor size. And it really depends on what kind of motor that we use. Okay, so in that one, we're going to take a look at we're just going to take a look at the insulated conductors. And it talks about the motor supply connection. So that's in 28104. So 28104 talks about it's essentially the insulation. So if I have a hot running motor, I'm going to need to get an extra piece of insulation, or the extra amount of insulation. I might have to use a 110 degree rated conductor, or it's a 90 degree rated conductor, or 75 degree. It depends on the rating of that motor. That's the only chunk, and there is some limitations in there that you want to read. And we don't need to make all of that doesn't need to be the same insulation rating. It's only the part that goes into the motor, and it talks about a distance, a minimum distance that it has to be. So it has to protect so it's not going to melt. Okay, and when we're taking a look at the overall conductor size, the overall conductor size is going to be found in 28. This is now the AUG size, 28106. And that's now our AUG size. That's to find that. So now we just transitioned over here, and this is all our power circuit, essentially from our main feeds all the way down to our motor. And it's going to be whatever that machine is going to be using, and any control requirements that we might have to have. Like I said, a neutral, maybe. If this is a 600 volt machine motor, I might have a 347. I might be taking a neutral down there so I can use a little bit lower voltage for my controls. But it all depends. That's the only difference that we would see with our power circuit. Generally speaking, fairly straightforward. We have to use those wire counts in here to be able to determine size of conduit or anything like that. So we need to find out the wire type that's going to be in there, the wire size, and then the number of the wires, and then we can determine what type of cable we're buying or what type of conduit we're buying. Hope this helps.